Dear students, welcome back. In the previous session, we have discussed about one type of rectification, that is half-wave rectification. So, rectification means conversion of alternating current to direct current. Okay, and this can be accomplished by either metal rectifier or by the diode wall. We know that it is having two types of rectification. One is half wave rectification and full wave rectification. We have already discussed about half wave rectification in the previous session, and the current produced in the half wave rectification is unidirectional, okay, and it is interrupted, unidirectional, interrupted and pulsating type of currents in half wave rectification. Now in this session we are going to discuss about full wave rectification. This is another type of rectification process. Okay, if you see in the full wave rectification, here the arrangement of the circuit is such that the direction of current is reversed during alternate half cycles of alternating current. So this is the alternate cycles of half cycles of alternating current. Here this wave is going to be reversed. So that means it is not change the direction here. So it is coming to the initial half wave type of wave. Okay, here the alternate half cycles of the alternating current is reversed. So the graph obtained in the full wave rectification is, it is unidirectional and it is pulsating type, but very important, these are uninterrupted flow of currents we can see. So for that reason you can see the continuous waves in a one direction, that is unidirectional, we can see in the full wave rectification. Okay, now this can be produced by different circuits which are used mainly by voltage halving circuit. So one is voltage halving circuit and another one is the Westinghouse Bridge, by using Westinghouse Bridge. So now first we are going to discuss about voltage halving circuit. In this circuit, either two metal rectifiers are used in the circuit, or with two anodes in a diode can be used in the other circuit. So these are the two ways we can use voltage halving circuit to get full wave rectification. Okay, so now first we are going to discuss about voltage halving circuit using metal rectifier. Okay, so we are using seeing the first type of circuit using metal rectifier. As we know that this is the symbol of rectifier, isn't it? The head of the arrow indicates the direction of flow of current. Okay, yes. If you see the circuit here, so this is the primary coil and next one is the A and B is the secondary coil. Okay. So and X and Y are the metal rectifiers here in this circuit. Now the both rectifiers, so normally these both rectifiers are connected to the each end of the secondary coil of the transformer. So if you can see, X and Y are attached to the two ends of the secondary coil. Okay, and both the rectifiers which are arranged to allow current to pass in one direction and both are connected to the same lead to the output circuit. If you can see, X and Y are connected to single output circuit, the same lead of the output circuit. The center of the secondary coil here, the center of the secondary coil is connected to the other lead of output circuit. Okay, two rectifiers, both the two rectifiers are connected to the same lead to the output circuit, and at the center of the secondary coil is connected to the other lead of the output circuit. Okay, so in this circuit, here A is negative and B is positive. So then how the flow of electrons will take place? From A to B, the electron should pass. But here, because of this rectifier X, the electrons is unable to pass in this rectifier, because if you can see the symbol of the rectifier, that means it can allow the current in this direction, but now if A is negative, the electrons are flowing in this direction. So this one is obstructing the flow of electrons at A. Okay, then what happens? How can we get the unidirectional force now? Okay, if you see at the center of the secondary coil at point C, this is the midway between A and B. So it is present at the midway between A and B. It is at zero potential. Okay, so zero potential means it is having more a negative charge. Okay, so consequently it becomes more negative than B. So then what happens? Electrons flow from C to the external circuit first and then back to the rectifier Y, and then back to the rectifier Y. Okay, and then it goes to B, and then it goes to B. Okay, so the current flows from C to the external circuit. From the external circuit it comes to Y and it reaches to B. That means now in this way of flow of currents, it causes a wave like this. Okay, and what about the remaining half? So this alternating half cycles of the current has to be reversed now. Then how the reverse of this wave is going to occur now? So when the reverse occurs, then what will happen? In the previous time, A is negative and B is positive. Now here B is negative and A is positive now. B is negative and A is positive now. Then how the current flows? So if you see, from B it has to flow current like this, but here at the Y the rectifier is stopping the flow of currents. Then again flow of current started from C only. Why? Because C is at zero potential. When you compare to A, C is more negative than A. Then electrons flow from C to the external circuit, and from the external circuit it is reaching to the rectifier X. So because it is negative, and so C is more negative. When compared to this C, A is positive. So then it reaches to A. Then this reverse of this wave is going to happening. Then already we have got this thing. And now again reversal of this alternating current is going to occur. Okay. how these changes are happening means, so because of changing this AB into positive and negative, and by using this metal rectifiers we are getting full wave rectification. Got it, ma? Yes. And then if you see in this full wave rectification, only half of the secondary coil of the transformer is used during each half cycle of alternating current, and so the EMF supplied to the output circuit is half of that induced in the coil. Okay, so in this way, this voltage halving circuit using metal rectifier giving full wave rectification leads to unidirectional uninterrupted pulsating currents. Okay, now we will see what happens in the case of voltage halving circuit using diode wall. Okay, so in this diagram, a diode wall, so this one is diode wall. Okay, this diode wall is having two anodes, M and N. Okay, two anode plates are used for getting the full wave rectified currents. Normally only one plate we have used in the description of diode wall. So here we are using two anode plates to get full wave rectified current. Okay. Again, this one is primary coil of the transformer, and AB is the secondary coil. Okay, and this one is the filament here. Yes. Now we will see how the connections are made. Okay, so when A is negative and B is positive, okay, when A is negative and B is positive, and the current cannot flow round the circuit from A as it is unable to cross the valve in this direction. So if you can see, this A is connected to positive plate N here. Okay. Now it is therefore from C. So C is already in zero potential. Okay. So therefore from C round the external circuit to the filament of the wall, the current will pass. So normally if you see the connections, so to the filament one electrode is connected to the external circuit, whereas this C is connected to the other electrode of the output circuit. Okay, now what happens? The electrons flow from C to the external circuit and it comes to the filament. Okay, from here the electrons are how it is moving? Yes, the electrons are released now in the diode and it is taken up by the valve M. It is taken up by the electrons are taken up by the anode plate M, and this one is taken up to the B end. So that is B is positive here, isn't it? So here it comes through this way. That means here what is happening? Now it is completing one alternating half cycle. Okay, it is rectified. Okay, here. So now we are going to rectify other half cycle into the same direction. Then what will happen? Again we have to change the charges in A and B. Now A should be in positive and B should be in negative. Then what happens? The current flows from the external circuit, isn't it? And then it reaches to the filament, and then the current is taken over by the N anode plane. Now the current is taken by the N anode plane and it reaches to the A, because now A is positive, isn't it, and B is negative. So now this current flows through the A and it is forming another wave which is caused by the reversal of the alternate half cycle of the alternating current. Okay, these are the circuits which are used for alternating cycles of the alternating current into the same direction, leading to unidirectional uninterrupted pulsated currents is called as full wave rectification. Okay, now another method is there for the full wave rectification. So by using Westinghouse Bridge, so we can see that Westinghouse Bridge. So this is another circuit which are used to get full wave rectification. Okay, in this circuit, as we know that this is a primary coil and this one is secondary coil. Okay, now in this 4 blocks of rectifiers are used. Here P, Q, R and S. These are the 4 blocks of rectifiers are used, and you have to see what is the direction of the flow of current by seeing this rectifiers. Okay, and in this the rectifiers are shown in a diamond arrangement, the input wires being connected to the opposite corners of the diamond. Here you can see these are the input wires which are connected to the opposite ends of the diamond. So the output wires taken from the other 2 corners. So these are the other 2 corners. The output wires are taken from the other 2 corners which are connected to the output circuit. Okay, that is external circuit. So the 2 rectifiers Q and S are directed towards one output wire. So if you can see, the 2 Q and S are directed to one output wire. Okay, and if you see the P and R rectifiers which are facing away from the second output wire. They are facing away from the second output wire. So when the direction of alternating current is such that if M is negative and N is positive, okay, the current passes from M, okay, through the rectifier Q. It will not pass P because it does not allow the flow of current. So the current will move from M to Q and then it reaches to the external circuit, isn't it? So to the output circuit, and rectifiers P and S, okay, P and S are preventing it taking any other pathway. So once it reaches the output circuit, the flow of current reaches to the C. Okay, the flow of current will reaches the C. From C it reaches to R and then it reaches to positive plate. So this is the directional flow which causes one wave. Okay, next in the reverse what will happen? Here next what the other option for the alternating current, we have to change the charges. So now N is negative, yes, now N is negative and M is positive. Okay, how the current will flow? yes, if N is negative, then the current flows from N to this point and it reaches to, so it will not allow this way, so it reaches to S, okay, it reaches to S and it goes to the output circuit now. It reaches to output circuit. Now it has to come back, it has to come back through the other output terminal, okay, and it reaches, and it will reaches to P and then finally it reaches to M. Okay, this is the pathway of current in the Westinghouse. Thus, the current always passes in the same direction through the output circuit and full wave rectification is obtained. Okay, so there is some drop in voltage owing to the resistance of the rectifiers, but it is very less than that which occurs in voltage halving circuit. So this is all about the rectification. Okay, that to full wave rectification. In the next session we are going to discuss about smoothing circuit. Why we are using smoothing circuit. So we will discuss in the next session. Thank you.